Today we are going to talk about combinations of error, combinations of of errors. So you will find errors in multiple cases. So first of all, let's think about when we are doing addition. So error in sum. So error in sum. So to find this, if um, if x equals to a plus b, this is a random equation where a and b are the measured value, and where we know the error of a and b, and we have to find the error in x. Think about it. Suppose a was a length, suppose 1 centimeter, and it has an error of 0.5 centimeter. Similarly, b is also a length, because principle of homogeneity means that you have to add them. Suppose it was 2 centimeter, and this time the error was of 1 centimeter. Then when you add these two, you need to find what will be the error, because it's not going to be 0.5, it's not going to be 1, it's going to be somewhere that comes up when you do this. So let's first of all see the formula. So let's see the formula. Now the maximum absolute error in x is delta x equals to plus minus delta a plus b, delta a plus delta b. So we are going to look at an example which will make this much more understandable for you. So let's think about it. Suppose we have x equals to a plus b. Let's say a is 1 centimeter and its error is 0.5 centimeter. So the plus and minus means that it can be 1.5 or 0.5, so you can add it or subtract it, and anything in the middle. It can be anything in the middle. So this is basically like saying this has a least count of 0.1 centimeter or 1 millimeter. This is actually the least count. So when you're adding the error, this is actually of a scale. So why of this is of a scale is because I have actually, so think about it. Why is this because suppose this is 1, this is 0, and the point can actually be anywhere. Suppose this is 1, this is 2, the point can actually be anywhere from this to this, right over here. So the error 0.5 means that there is a uncertainty of 0.5 centimeter when going from there to there. So I think that was pretty confusing to understand, because I'm not stating it pretty obviously, since I'm also thinking how to state it more obviously, but I'm not quite sure. So let's just not focus on that. Suppose b was 2 centimeter plus or minus 1 centimeter. So there is a error, not an error, there is a range that it could be, which is plus 1 centimeter. So now if you just add a or b, first of all you will have to add the first part, which will give us 3 centimeter. But is it 3 centimeter exactly? No, not at all. It can differ by these factors. So these factors will come to play now. So let's look at the ranges it could be. Suppose it was minus 0.5 centimeter. The actual value was minus 0.5 centimeter, and where this part was 1 centimeter, you would get 0.5 centimeter. Suppose this part was positive and that part was negative. I'm taking the maximum case, you could take any number, so this could actually even be 0.7. It can be anything from the range of -1 to 1. So right here you will actually get minus 0.5 centimeter. So let's look at some other cases. Suppose both are positive. If both are positive, you get plus 0.5 centimeter. So let's write a plus right over there. And finally, if it both were minus, you will get minus 1.5 centimeter. So if you look at the maximum case, there are two cases of maxima, which is this. Don't focus on the sign, just look at the number. And this. So when talking about the maximum absolute error, the maximum absolute error is going to be plus or minus, since there are two of them, plus or minus, and which is delta A plus delta B. Delta A plus delta B, which in this case will be just 1.5 centimeter, which means this something which I measured can be 4.5 centimeter or 3 minus 1.5. It will give you 1.5 centimeter. So this can be in the range of, so which means it can be in the range of 1.5 centimeter to 4.5 centimeter. So that's the range. This error tells you the range. So we just looked at the maximum and the least possible errors. So these are the maximum values. So the maximum absolute error will be this. So now let's look at another one. So I explained this one in very detailed, I think. In the next one, we are gonna be a little bit more quick. So the next one is error in difference. Error in difference. Error in difference. Difference. And when we are talking about this, these part are delta A and delta B respectively, not the plus or minus. We don't look at the plus or minus right now, okay? Unless you're doing absolute error, but we are doing maximum absolute error. In that case, we don't have to look at the plus or minus. If you're doing absolute error, then you would have to look at the plus or minus. So the difference in error, so if x equals to e minus b, the maximum, so now the maximum absolute error in x is delta x equals to plus or minus delta A plus delta B. So you might have a little bit of question, why not minus? Why not minus? So let's take this example once again. Suppose it was subtracting, so you would subtract 1 minus 2, you will get minus 1 centimeter right over here. But when you're adding, you want the maximum values, and still you get the maximum values when adding them, right? So you will have to still add them. We don't subtract the errors because we want the maximum number. To get the maximum number, you will have to add them. If it was minimum absolute error, then you would subtract them. But since we are always searching for the maximum absolute error, you will always have to add them. But if there is the question of maximum absolute error in A, you will have to write delta A plus minus delta A. The maximum absolute error in B will be plus or minus delta B. So since we are talking about x, it will still be addition since you want the maximum value. And if you look at over here, this is delta A, delta B. You get the maximum values of the error when you add them, right? So now let's talk about the third case. The third case that we're going to talk about is error in product and quotient. I don't know if it's called quotient, but I'm going to call it quotient, okay? So if x equals to a times b, or x equals to a by b, so a divided by b, then maximum possible value of relative or fractional error fractional error will be. So you might have a question, why are we not looking at absolute maximum error? It's because it's much more easier for us to look at the relative or fractional error. So it's a much more easier formula to digest. That's why we are looking at the relative or fractional error, which is so the error in x divided by the value of x will be plus or minus delta a by a plus delta b by b. So this will be the formula. So you might have a question, why is this the formula? So I will also show you why this is the formula pretty quickly. So look at the formula, remember the formula. Okay, so let's derive the formula. We are gonna do both of them. So let's derive both of them. So first of all, for x equals to a times b, we are actually gonna use the log function. For this you can use any log, but I'm gonna use the natural logarithm, which will give us this ln a times b. So right over here, due to the properties of log, which we will learn in a math video that might come up someday, you will actually see that multiplication is basically addition in log. Now we are at this point. Now let's go back to division. If you use ln or natural logarithm, you will actually get this, and division is basically like subtraction. So you will get ln a minus ln b. So now we have to differentiate it. So we are gonna differentiate it, and this only works for small approximations. So only for small approximations. So if it is a very big approximations, then it won't be accurate. So now if you differentiate it, you will actually get for this side. So let me make this one another color so that it's not that confusing. For this side, you will actually get delta x by x equals to delta a by a plus delta b by b. Actually, this is not delta b, delta a or delta x. It's actually supposed to be dx, dA, and dB. But since it is only for small approximations, you can write it this like that. But for this side, it will actually be dx by x equals dA by a minus dB by b. Since we are doing small approximations, dx is basically delta x. So dx means a small change, a very small change in x, whereas delta x means a change in x. It does not consider that it is small. But since we are taking it for small approximations, we will have to consider dx and delta x as equivalent. So we can write delta x by x equals to delta a by a plus delta b by b. And right over here, you will actually get delta x by x equals to delta a by a minus delta b by b. So you might have two questions right now. Where did the plus and minus go, and why is there a minus right over there? This is just the error. But when we are looking at absolute error, we would maximum absolute error or maximum relative maximum possible value of relative or fractional error, we will have to have this part maximum. So that's why we will have to have in plus, and the plus or minus because the same reason when we talked about addition and subtraction. So you will actually get, so in result, when you combine this and that, you will see that both product and division will have the same maximum possible value of relative or fractional error, which will be plus minus delta a by a plus delta b by b. It's going to be plus so that it will be maximum. So this was the derivation, and this only works for very short what I mean to say is very small approximations. And now another question that you might have is, why is it in a ratio? How to understand that? Why is it in a ratio? Now let's think about it. I will always take this error, which is plus minus 1 centimeter. Now let's take two examples. Suppose there was 1 centimeter plus 1 centimeter plus 1 centimeter error. So if there was this one, there was one, there was something like this, and another one, there was 100 plus 1 centimeter. So in this case, think about it. Here the plus 1 plays a much more significant role, which I'm gonna show by red color, than this one. This one shows a much less significant role, since 100 is a bigger value, and if this value goes on being bigger, you will see that it will be much more scary. So let's think about it. Let's take very small approximations and big ones. So right here, this could also be 2, which is a very big number compared to 1. It's twice the amount. But whereas if you take the maximum, it will be 101, which is basically like 100. That's why when we're talking about errors, we always talk about relative errors when we're talking about errors in product and quotient. If you were adding, the errors would just add up. So it's no problem over there, since these values don't matter. But when you're dividing or multiplying, these values matter a lot. Think about it. Think about it. Okay. So now, let's talk about the errors in power. We talked about errors in multiplication, addition, subtraction, division. Now let's talk about errors in power. So the fourth one is errors in power. So errors in power. If x was e to the power n, so there is a power, then maximum relative error, in x is delta x by x equals plus minus n delta a by a. So how do you do this? You also derive it by the similar way, not the same way. Let's say it's a very similar way to the previous one. So this is a very simple case. We will also talk about a little bit complicated case and how to understand that. So let's write the complicated case as well. Then I will show you the derivation in the complication case, which will make it much more easier to understand in the simple case. So the other one is, if x equals to e to the power n divided by b to the power m, then maximum relative error is in x is delta x by x times plus or minus n delta a by a plus m delta b by b. So this is a little bit more complicated one. So if you understand both of them, this one, then you will of course understand the first one, the first case. So now, before coming to this, let's clarify one more thing that we talked about right over here. We talked when we were talking about multiplication and division, we only talked about that you take ratios in order to, because 1 plus 1 and 100 is to 1, they matter when we're talking about multiplication and division. So let's clarify that a bit more. To clarify that a bit more, when we are talking about multiplication and division, percentage matters. What? Percentage matters. But when we're talking about addition and subtraction, absolute error matters. So let's repeat. When talking about multiplication and division, percentage error matters or relative error matters, whereas when we are talking about subtraction and addition, absolute error matters. So look here, these are relative error of this is the relative error of x, relative error of a, relative error of b, right? And similarly right over here, um, this right over here, if you take if you see what will be the error in this case, it's 1. So I will show you another example so it will be much more easier. Suppose I have a 5 centimeter rod and it has an error of 1 centimeter. Right now in this case the percentage error is just 25%. Wait, let me think about it. 20%, because the percentage error will be 5 minus 1 by 5 times 100%, which will give you 4 by 5 times 100, uh, which is actually 80%. Wait a second. I think I did a mistake. Sorry. Once, let me check. Okay, let's go back to the formula so that we can understand it much more clearly, because even I got confused. So going back, the percentage error is true value minus observed value. So this is actually this absolute error by true value into 100%. So let's go back here. When we have this case, this is actually the absolute error, right? It's the absolute error. So we have 1 by 5. The units cancel out, so I'm not writing that. So error by true value into 100% gives you 20%. So when we have an error of so let me make this another color, of 1 centimeter in 5 centimeter, it will be 20% error. But when we're talking about suppose 100 centimeter with still 1 centimeter error, we will. Oh, my mic just went out, so let's do some dubbing, right? So suppose if I had 100, then I would get 1% error. So this means that even though I have the same numeric error, which is 1 centimeter, I still get different percentage error. That's why when you're multiplying or dividing, you get different results. Whereas when you're adding, it does not matter. So now we are gonna take a look at multiplication. So let's write q times q is equals to a times b, and let's say a has a percentage error of I don't know what. Let's see what he writes. 3%. So positive or negative. So let's say positive 3%, and b has a percentage error of positive 3%. I think that makes it a little bit confusing, so I think I change it to 2. Right. So think about it like this. Whenever you're trying to find the percentage error in Q, you're just going to add them up since you're multiplying them. Since you're multiplying them, so if you add them up, you will be 3% plus 2%. And this is the same as doing the relative error, but you're multiplying the relative error by 100%, which means you're basically doing the same thing. So now if I go back, I will probably write 5% right over here. So right now, this is the percentage error as well as the maximum percentage error as well. So if in general cases, you will be given plus or plus minus or minus. So if you're given plus or minus, you are generally required to find the maximum percentage error. Whereas if you're given plus or minus, you generally need to find the percentage error as it is. So I think I will talk about some things like random things over here. No idea. I don't know what he's talking about. Now let's move to the next one, which is q equals to a divided by b. So I think I take the same percentage. So let's say the percentage error in A is plus 3% and in B is plus 2%. So in this case, since you're dividing, you gotta subtract the percentage. So it will be 3% minus 2%. So that will be actually the percentage error. But I write 5% right over here because it's supposed to be plus 5%, but this is supposed to be the maximum percentage error if the question has asked for it. but the percentage error, which I will probably show, and it's also shown right over there. I'm showing the formula where there is a minus when we are dividing. So this will actually lead, if you have to find the percentage error, come on, write it, man. It's gonna be plus 1%. I should have written plus in all the cases, but never mind that. I'm changing the color to make it look pretty, I guess. So let's wait what I write. Let's see. Hmm. So I saw some formulas. Let's look at some formulas. I think I will try to explain the formula. So let's see. So I wrote x equals to a to the power n divided by b to the power m. So let's see what will be the percentage error in this case. So first of all, I took logarithmic in both sides. So I took ln on both sides. So it will be ln x equals to ln a to the power n divided by b to the power m. Now using the properties of log, I can just convert that to, it will be converted like this. So it will be subtraction, and I'm adding the modulus sign because it's much more correct to write the modulus sign rather than not writing that. So now I will probably, I don't know what I will do. I'm not even sure. So let's see what I do. So I just use another property of log which allows the power to jump forward. So I put the power in front of the log. So I'm multiplying n times something. So in case log, and I'm differentiating it. So and why you have might have a question which thing I'm differentiating it. I'm differentiating the first part, which is the ln x, and as well as the n ln a minus n ln b part. So this is a dubbing, so like this might be very confusing since like my motions and my voice are not matching, but what can I do? It seems like I'm coloring that to make it much more clear to show which one that I'm differentiating. So it's pretty clear which one I'm differentiating right now. So now I think I will differentiate it. So ln x will just be dx. So I think I wrote dx. Yep, I wrote dx by x. But if your like percentage error is very less, like 1, 2, 3, 4%, so you can write delta. Delta meaning just the actual change, whereas more dx means small change. So it's approximation. And in the other cases also, it will be dx. But since we are taking small approximations, it will actually be delta x. Since this doesn't matter. So now I think I will write it much more formally. So I can also take the n common. Let's see if I do that. Let's hope I do that. Okay. I think, wait, I actually wrote n over there. I think it, yeah, I got stupid because like when the power comes in front, instead of the n, it's supposed to be a m. So I think I will correct it over here. M delta b by b. So it's still plus since this formula is always for maximum relative error, and yeah, I changed it since that's supposed to be m. I wrote n in both cases. That's not supposed to happen. So let's see what happened next. I think I'm talking about something like I'm talking about my error and making it much more clear to everyone else. But let's see what happens. I'm waiting for the answer. What? Come on, change the page. Bro, change the page. Quick, 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 quick. Okay, now the page has changed, so let's see what we will get right now. He writes e equals to a to the power n. So I think I will teach you how this formula actually works. Why are you taking that away? So the percentage error in A will just be delta A by A percentage in symbolically. So it's just the relative error of A multiplied by 100%. So um, this is actually what I'm representing, but in some places you can just represent it by a percent. So that will be a symbol, whereas this is like a formula. So so this, suppose that was percentage error was a 1%, and I said x equals to a to the power cube. So a to the power cube is basically a multiplied 3 times, right? So since it is a multiplied 3 times, I can just use the formula that I used for the multiplication case, like q equals to a into b. So I will just add them up. So that will be plus 1%, plus 1%, plus 1%, since I'm finding the maximum percentage error. So this will be 3%. So no plus, no minus right now, but it's 3%. So that the formula also works in this case. That's what I'm trying to say. Since you're just multiplying by a and n, so if I had multiplied n, which was 3 in that case, so it will be 3 into 1%. So that will also lead me with 3%, which means this formula is valid, like it works. Yeah, we proved it by some other method. So it's much more easier to grasp a concept once you know the formula and you know some other backgrounds and you connect it all together, so you can relate all of them. And I think I'm saying bye bye in the video, but I'm not quite sure. Let's say bye bye and see you in the next video. Bye bye.